Whenever a finger comes into touch with any surface, it leaves behind a host of chemicals as sweat residue. This residue is also called latent fingerprint. For development purposes, one or more chemicals in the sweat residue has to be chosen and converted into some color derivative so that whatever is latent, whatever is hidden becomes visible and we say that the fingerprint has been developed or the fingerprint has been detected. There are a host of chemical methods. Each one of them tags a particular chemical in the sweat residue and gives a color derivative and renders visibility to the latent fingerprint. For example, ninhydrin reacts with the amino acid and protein content of latent fingerprint and gives purple colored prints which are quite clear and sharp. R8O method is another chemical method in this series. When we study the chemicals which are present in sweat residue, we may broadly divide them into two parts. Firstly, the water soluble compounds like sodium chloride, potassium chloride, magnesium sulfate and amino acids. Second, the water insoluble compounds like the proteins, fats and lipids. In the second category, there is a further subdivision. There is a robust fraction which comprises mainly of proteins and peptides, and there is a labile fraction which comprises mainly of fats and lipids. R8O method fixes the second robust component of fingerprint residues in the sweat. These residues, lipids as well as fats, as I said, are water insoluble and they are robust. They are soluble in organic solvents like hexane. For this purpose, R8O should not be dissolved in such solvents which are totally non-polar because they will simply wash away the sweat residue. Practically, R8O is dissolved in a 50-50 mixture of methanol and water. It interacts with fats and proteins. Surprisingly, there is neither a chemical reaction nor physical adherence of this stain to the fats and lipid component of sweat. It is basically a thermodynamic phenomena. The R8O molecules get dispersed within the cavities of the fats and lipids. The entropy of the system increases and they impart red color to the ridges. The color is very sharp. You don't even need a lens to observe them. The prints are very clear. Hardly any of them is faint. But then, this method is very simple. It develops fingerprints on a large number of porous items, including photostat paper, kraft paper, corrugated brown paper, as well as thermal paper. Yet another very big advantage is that it can develop fingerprints even if the porous item is wet. The reason is that the fats and the lipids are insoluble in water. So even after washing the surface, in this case the porous item with water, after the fingerprint has been impinged on it, the fats and the lipids, they retain their position on the ridges. They are not carried away, and therefore R8O method can develop latent fingerprints using these chemicals. A substitute is the physical developer method. This method also gives quite clear prints on porous items which are wet or which are dry. But then this process is very cumbersome. It involves a large number of steps. The apparatus has to be absolutely clean. Compared to that, R8O method is very simple. It is cost effective. It's a one-step process, doesn't require any specialized training. Even an amateurish hand can handle it. And the most important advantage of R8O method is that when all the chemical methods of detection of fingerprints fail, this method can still be tried out. It cannot be the other way around.
Dear students, after studying this module, you shall be able to know that the oil red O reagent develops latent fingerprints on dry and wet porous surfaces. The oil red O tags insoluble lipid and fat constituent of fingertip sweat to reveal red colored ridges. The phenomenon by which oil red O detects fingerprints is guided by thermodynamic considerations. And lastly, after reading this module, you'll come to know the merits and demerits of oil red O technique of fingerprint development. You see, oil red O, also called solvent red 27, is a lipophilic dye, which means that it stains fat and lipid components in biological samples. It is also used to stain oil and waxes to a red hue. Its structure, as depicted in the given figure, is based on diazoskeleton. Oil red O is a lipid stain that is used for enhancing latents produced by the lipids commonly found in fingerprints, foodstuffs, oils, cosmetics, or other fatty substances. Oil red O has been found to be particularly useful in revealing latents on porous surfaces that have been wet. Compared with physical developer, the oil red O technique is much less complex and gives results of impressive clarity and intensity. Now, let us see the uses. Oil red O is one of the dye used for Sudan staining. Similar dyes include Sudan 3, Sudan 4, and Sudan Black B. The staining has to be performed on fresh samples as alcohol fixation removes most lipids. Oil red O largely replaced Sudan 3 and Sudan 4 as it provides much deeper red color and these stains are therefore much easier to see. In pyrotechnics, oil red O is used in some compositions of red colored smokes. It is also used for making dyes. Now, let us have a look on forensic application of this dye. When staining, oil red O can make fat more visible in various cuts in pathologies. It is also used in a technique. The method is called as the dye oil red O, discovered in 2004 by Alexandre Boudouin for staining latent fingerprints. This technique allows the development of latent fingerprints on porous exhibits such as paper, cardboard, etc., that are dry or wet. It mainly targets fat deposits on the surface of porous exhibits. It is a non destructive technique which does not destroy the exhibit and doesn't prevent the use of other techniques. It is a safe alternative to the physical developer method and is also used in sequence with other methods of fingerprint development. Oil red O is used to detect latent fingerprints on dry and wet porous items like paper and cardboard. Although the physical developer can also lift latent impressions from wet porous surfaces, the method is a multi step one and requires immersion of delicate paper like articles in a sequence of working solutions. Compared to that, the operational steps of oil red O method are simple. The reagent develops clear, stable, red colored fingerprints which may be discerned in natural light. Now, Let us see a study by Kimberly and Alexander. Kimberly and Alexander examined whether all red O would interfere with or improve the recovery of latent fingerprints on three types of wet and dry paper when used in sequence with other methods. Results indicated that on its own, ORO provided excellent recovery of latent fingerprints on both wet and dry paper, and in most cases, further development with additional methods was unnecessary. However, the addition of physical developer as a final procedure in the recovery sequence can be added without being influenced by the insertion of ORO. On its own, ORO has proven to be one of the best physical developers for the recovery of latent fingerprints on white, craft, and thermal papers that have been wet. The ability to apply other methods to enhance the recovery of latent fingerprints while still using ORO will help forensic examiners who need further development beyond ORO. The research involved wiping the fingers of six subjects on their forehead and then rolling their fingers on each of three paper types, that is, white, craft, and thermal. Each paper was cut down the center so that half of each fingerprint was subjected to one sequence excluding ORO and the other half was subjected to the sequence including ORO. The two sequences tested for the dry white and craft paper were DFO, ninhydrin, and physical developer on one half and DFO, ninhydrin, ORO, and physical developer on the other half. The wet papers used the same two sequences except that on the day of testing, each paper was submerged in a water basin for 1 hour prior to testing. Latent fingerprints on thermal were gathered from 9 points of scale received from each of 7 companies. Each paper was divided into 3 sections and all testings were performed on dry paper. Thermal paper fingerprints were developed using ninhydrin and ORO. At the end of the 30-day testing period, all fingerprints were analyzed and compared. Now let us see the theory part. The chemical entities present in fingerprint residue may be broadly classified into two types. Number one, water soluble, and number two, water insoluble. The amino acids and inorganic ions such as sodium, potassium, and chloride belong to the water soluble class. The water insoluble class includes proteins, lipids, and fats. In order to gauge the pathway by which oil red O detects fingerprints, it is pertinent to further subdivide the water insoluble category into two fractions: the robust fraction, which includes proteins and peptides, and the labile fraction, which includes fatty acids, triglycerides, and lipids. Whereas the physical developer interacts with the robust fraction components of sweat residue. Oil red O tags the labile fraction entities. The labile fraction is so named because its components undergo rapid chemical transformations. This fraction is soluble in nonpolar solvents like hexane and petroleum ether, but sparingly solvent in polar solvents like water and methanol, a chemical reagent which fixes the labile fraction of sweat residue for developing latent fingerprints should not be dissolved in a non-polar solvent. Otherwise, the solvent will wash away the labile components before these have a chance to interact with the developing reagent. It is for this reason that the oil red O is dissolved in methanol water mixture. On coming in contact with the labile components of the fingertip sweat, these stain partitions between the original solvent mixture in which it is less soluble and the fats or lipids in which it is more soluble. The molecules of oil red O gets preferentially dissolved in fat and lipid components and imparts red color to these biomolecules. The preferential solubility of oil red O in fats and lipids is a physical phenomenon which is controlled by thermodynamic considerations. As the molecules of oil red O become dispersed in the lipophilic media, the entropy of the system increases. Entropy is a measure of disorderliness in a closed system. Greater the degree of disorderliness, greater the positive value of entropy, and more stable is the system. When oil reed becomes dissolved in fats and lipids, its molecules become randomized in the sweat residue, thereby increasing the entropy. The fallout is that the red color imparted to the fingerprint residue is more intense than that of the original stain. The outcome is that clear red colored ridges become visualized. Now, let us see the methodology. Two test solutions are prepared when fingerprints are to be detected on dry or wet porous items by oil red O reagent. A. Stain solution. It is prepared by the following steps. Oil red O is dissolved in methanol. Sodium hydroxide is dissolved in water. Next, the aqueous solution of sodium hydroxide is added to the alcoholic solution of oil red O. The contents are thoroughly mixed and filtered. Then the filtrate is stored in a dark bottle and kept away from light. Now the stain solution remains stable for about 8 months. B is buffer solution. It is prepared in the following steps. Sodium carbonate 26.5 gram is dissolved in water approximately 2 liter and shaken till it completely solubilizes. Then concentrated nitric acid of 18.3 ml is added to the sodium carbonate solution in small lots and with constant stirring. The solution is diluted to 2.5 liter by adding water. Now let us see the test procedure. Latent fingerprints may be developed on dry or wet porous articles by following sequences of steps. Number 1. The article bearing the latent impression is immersed in the stain solution and shaken for about 90 minutes. The tray in which the article is agitated is normally covered with a paraffin film to avoid loss of methanol due to evaporation. The article is removed from the stain solution and drained. It is immersed in the buffer solution to adjust the pH to 7. The buffer solution neutralizes the sodium hydroxide content absorbed onto the item as a result of its immersion in the stain solution. Removal of the alkali from the article stabilizes the developed prints. The article is rinsed in distilled water and allowed to dry under natural conditions. Red colored fingerprints develop on pink background. Now let us have a look on assessment of oil red O method. The oil red O reagent develops optimum quality fingerprints on different varieties of paper, including craft paper and corrugated cardboard, the latter two being brown in color. Latent impressions impinged on thermal papers, followed by impressions in water for 2 hours, could be developed even after 30 days with oil red O. Likewise, imprints deposited on photocopier paper followed by soaking in water for 24 hours could be developed after a lapse of 30 days. Oil red O technique may be used after all routine amino acid specific reagents have been tried out without success. It is pertinent to compare the performance of oil red O method with the physical developer technique, which too develops fingerprints on dry and wet porous surfaces. Although oil red O gives better results on photocopier paper than on craft paper, the reverse is true of physical developer. Oil red O outperforms physical developer so long the latent impressions are fresh or at the most 4 weeks old. For more aged impressions, physical developer perform better. No doubt, oil red O method has a fewer steps as compared to physical developer technique. Yet, the immersion time of 90 minutes in the stain solution make the overall process slower. So now let us summarize this chapter. In this chapter, we have learned that oil red O is a lysochrome dye which has been used for staining lipoprotein. It develops red colored fingerprints on dry and wet porous items. The process is simple and involves three steps. Number one, staining. Number two, neutralization. And the last one is drying. Then we have come to know that the quality of developed prints is up to the mark, provided the impressions are revealed within a span of 4 weeks. For prints which are more than 4 weeks old, the physical developer method is more suitable. Then, in this chapter, we have learned the chemical entities present in fingerprint residue may be broadly classified into two types. Number one, water soluble, and number two, water insolubles. Then we have come to know after reading this chapter that in order to gauge the pathway by which oil red O detects fingerprints, it is pertinent to further subdivide the water insoluble category into two fractions. Number one, the robust fraction, which includes proteins and peptides, and the labile fraction, which includes fatty acids, triglycerides, and lipids. The preferential solubility of oil red O in fats and lipids is a physical phenomenon which is controlled by thermodynamic consideration. Then we have come to learn that when oil red O becomes dissolved in fat, and lipids, its molecules become randomized in the sweat residue, thereby increasing the entropy. And lastly, we have learned from this chapter that two test solutions are prepared when fingerprints are to be detected on dry or wet porous items by oil red O reagent.